last section of the semester, section 5.8, a few more integration rules for the transcendental functions. The transcendental functions, I kind of think of those as just non-polynomial. That's not exactly how to characterize them, but you'll generally see them as the logs, the exponentials, and the trig functions. So one refinement of a rule that we got back in section 5.4 is that the integral, the integral from 1 to x of dt over t, if you look at that area accumulation function that we defined earlier, can be thought of as just the natural log of x, because if you do an antiderivative for 1 over t, you get natural log of t. Evaluated at the upper limit, you get natural log of x minus natural log of 1, which is 0. So this is just a refinement, and notice that what's different about the rule that we got in section 5.4 is that we don't have to put those absolute value bars on there. Here, for the indefinite integral, we don't know what values the variable t is ranging over. But here, we're starting t at something that's positive. So we don't have to hit the absolute value bars on that variable there because t is positive. And natural log only takes positive inputs. So really quickly, I want to introduce the inverse trig function integrals, and you guys can get these from going back when we did implicit differentiation and looking at the derivative rules that we got for the inverse trig functions. You may have to review them, but the derivative of inverse sine is 1 over root 1 minus x squared, and derivative of inverse tangent and inverse secant. And if you recall, derivative of inverse cosine, cotangent, and cosecant were very similar, except that they had a negative sign. These were real easy to memorize. You just had to memorize half of them and then flap a negative sign on for the other ones. Well, if you integrate a function with this form, you get an inverse trig function. And if you integrate a function of this form, 1 over 1 plus x squared, you get an inverse tangent function. And so using those derivative rules for inverse trig functions, we can come up with some corresponding integration rules for functions of those forms. And our results are inverse trig functions. And if you want the others, so these are listed for you on in your text on page 314. And if you want the others, you can figure them out. Like if you had this integral with a negative sign, that would give you inverse cosine. But you can figure those out by reviewing or revisiting section 3.8 on implicit differentiation. In the next video, we'll work a couple of examples.